Hey kiddos! Now let us move on to adding and subtracting radicals. So let's just do a quick little review of simplifying the following expressions, aka basically combining like terms. So we have here 3x plus 2x. Notice they both have the value of x, so I can actually combine these. And 3 plus 2 gives me 5x. B, 8y minus 9y. Notice they both have y values, so therefore I can combine them, and 8 take away 9 leaves me with negative 1y, or just negative y. C, I see that's a 9x, and this is, a 12y. You cannot combine, so therefore the simplified answer would be 9x plus 12y. And D, negative 3a plus 6b. Again, the variables are not the same. They're different, so therefore I cannot add these. So therefore the simplified version would be negative 3a plus 6b. The same concept pretty much applies to when we're adding and subtracting radicals, okay? So always first check to see that you can simplify your radical. So you want to break them down as much as you can, okay? And then you want to combine like radicals. So anything with for example here, a square root of 10 can be combined with anything with a square root of 10, okay? And in doing that, so when I would combine these two, so let me underline them so you can see a little better. I'm talking about 3 square root of 10 plus the 5 square root of 10, I can combine those because the radicals are the same. Okay, so we would simply, in this case, add the coefficients. So 3 plus 5 gives me 8. And then the radical doesn't change, okay? It's going to stay the same. It's going to stay square root of 10. Notice I had this plus square root of 5 left over. That doesn't combine with anything, so I just bring it on down because I don't want to forget about it. And that would be the simplified version when we add. Now for subtracting, the same rules apply. The only difference is you're subtracting, okay? So in this example, I got square root of 11. Does anything else have a square root of 11? No. So moving on. This negative 4 square root of 7 does combine with the negative 3 square root of 7. So I'm not going to forget about this square root of 11 that I didn't deal with, so I'm going to bring it down. Now, to combine the ones that are alike, negative 4 square root of 7 minus 3 square root of 7 is going to be negative. Combine the coefficients for negative 4 minus 3 is negative 7 or minus 7. And remember, the radical stays the same, doesn't change. And that would be the most simplified version of that question. All right. So, example 1. Basically looking to combine like terms. So, 4 square root of 5. The plus 7 square root of 5. And notice the 2 square root of 2 doesn't combine with anything. So, add the coefficients. 4 plus 7, 11. Radical stays the same, doesn't change. And I bring down the plus 2 square root of 2. There is the solution. Number 2. 8 square root of 10. Anything else got a square root of 10? Nope. So that doesn't come out with anything. But I got a negative 7 square root of 3 and a negative 6 square root of 3. So that doesn't combine with anything, so I'm not going to forget about it. So I'm just going to go ahead and bring it down. Now, negative 7 square root of 3 minus 6 square root of 3 can be combined. Let's subtract those coefficients. So negative 7 minus 6 is negative 13 square root of 3. Remember, the radical stays the same. All right, awesome sauce. And guess what? I want you guys to yo, the last 2 yo. All right, so let's say none of the radicals look the same. Well, remember, the first thing you're supposed to do anyways, you always simplify the radical if possible, okay? So In this case, I know that I can actually simplify the square root of 24. Square root of 6, that can't be simplified any further. Okay? So we can break down though, or create basically our little factor tree for 24. 24 is 6 times 4. 6 is 3 times 2. And 4 is 2 times 2. Squiggle you out, squiggle you out, squiggle you out. Looking for pairs. Dun. Got one pair of 2s, and I got a 2 and a 3 left over. So, when we put this back in, don't forget about that 3 because it's already there, okay? So you got 3 times, because that's basically what this is saying. Hopefully you guys catch on to that. This is saying 3 times the square root of 24, okay? So 3 times, and we're going to rewrite square root of 24 because we got it to be 2 square root of 6. 2 square root of 6 plus 2 square root of 6. Well, we need to multiply here. 3 times 2 is 6. 6 square root of 6 plus 2 square root of 6. And what do you realize? My, oh my, we can combine our radicals because they both have square root of 6. So add the coefficients here. 6 plus 2 is 8. Keep the radical the same. Yay! All right, so here we go again. 18, square root of 18, and plus the square root of 32. Obviously, right now we can't add those together, but these radicals aren't simplified. So let's get to factoring and making our trees for 18 and 32. 18. 2 times 9. 9, 3 times 3. Squiggle you out, squiggle you out. Pair of 3s, 2 left over. Square root of 18 is going to break down and simplify 2, 3, square root of 2. Now moving on to 32. 32. 8 times 4. 8 breaks down to 2 times 4. 4 is 2 times 2, and this 4 is also 2 times 2. Squiggling action. Squiggle, 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 squiggle. And now, pair of 2s. Ooh, another pair of 2s, and 1, 2 left over. So I'll multiply my pairs. 2 times 2 gives me 4. And I had that 2 left over, so square root of 2. Now, let's rewrite the problem. Square root of 18 was 3 square root of 2 plus, there's where I get the plus sign from. Square root of 32 was 4 square root of 2. Well, what do you know? They both got square roots of 2's, which means we can combine these bad boys. So 3 plus 4 is 7, and the square roots of 2 just tag along and stays the same. That would be the answer. Moving on. Number 2. All right, so we're going to simplify first those radicals. So square root of 28, we got to break that down first. I'm not going to deal with the square root of 7 because hopefully we all recognize by now that you can't break down the square root of 7 any further than just 7. So let's deal with 28. 28. I like the 2 and 14. 2 times 14 is 28. All right. 14 breaks down to 2 times 7. Squiggle you out, squiggle you out. I have a pair of 2's and a leftover 7. So that is 2 square root of 7. Now, be careful when you're plugging these back in, because I guarantee you this is where one of you people out there, is going to make a mistake. This square root of 28 has a 5 already in front of it. So don't forget about it, okay? 5 times. Now, the square root of 28, we change to 2 square root of 7. When I break that down, multiply 5 times 2, we get 10. Square root of 7. Then we'll bring all that madness down, which was minus 9 square root of 7. What you should realize is we can actually combine those because they both have square roots of 7. So 10 take away 9 is 1 square root of 7, or basically just square root of 7. Next. All right, Negative 2 square root of 54 plus 2 square root of 24. Clearly, we can't just add these right now because of square roots. The radicals aren't the same. So let's see if we can break down these radicals. So let's deal with the square root of 54 first. 54. 9 times 6. 9 breaks down to 3 times 3. And 6 breaks down to 3 times 2. Squiggle you out, squiggle, squiggle. And I got a pair of 3s, and then we got a 3 and a 2 left over. So that becomes, so square root of 54 becomes 3. Square root of 3 times 2, 6. 24. 6 times 4. 6 breaks down to 3 times 2. 4 breaks down to 2 times 2. Squiggling action. Squiggle, squiggle, squiggle you out. Now finding my pairs. Got 1 pair of 2s and 3 and a 2 left over. Okay? So that simplified is 2 square root of 6. Now remember, both of these have values in front of them, so don't you forget about it. Okay? So for the 54, when I'm rewriting it, it would be negative 2 times 3 square root of 6 plus, when I'm rewriting the 2 square root of 24 part, got that 2 there, times 2 square root of 6. All right, when we simplify that, so negative 2 times 3 is negative 6 square root of 6 plus 2 times 2 is 4 square root of 6. Well, remember, because both of those terms now have square roots of 6, which means they're alike, which means we can combine them. Negative 6 plus 4 is negative 2, and you keep the square root of 6 the same, and that would be the answer. Number 4, you already know. Oh, yo. Just to throw this in here, we're going to talk about distributing. Now, distributing is not really, distributing is not adding or subtracting, because we know distributing is multiplying, which is something we've already talked about, okay? But typically, after we distribute, normally you do have either addition or subtraction going on, so that's why I have it in this specific notes. So, as you can see here, first thing that you need to do is distribute the radical. Remember, when you're multiplying, it's pretty straightforward. You multiply outside numbers with outside numbers, numbers under the radical with numbers under the radical. So distribution is the same. You got to distribute it to everything inside the parentheses. So square root of 3 times the square root of 7 is the square root of 21 plus square root of 3 times the square root of 5, square root of 15. Okay, beautiful. Now, we got to simplify them. Okay, square root of 21. So here's where factor trees come into play. 21, well, guys, just use the numbers that were already given to you. Already, no need to sit here and try and reinvent the wheel. Ooh, 7 and 3, they cannot be broken down any further. So, yeah, so square root of 21 is the lowest it's going to go. Okay, square root of 15. It's 5 times 3. Yeah, that also is the lowest it's going to go. So rewriting it, it's the exact same. Those two, they don't break down. So notice, combine if necessary. In this case, we cannot combine, so therefore that would be our final answer. I'm going to be so kind as to let you guys do number 1 on your own because it's a little bit simpler looking than number 2. So we're going to attack number 2 together. Now remember what I said. Numbers on the outside of the radical multiply with numbers on the outside of the radical. Numbers under the radical multiply with numbers under the radical. All right? Okay, so here we go. 2 square root of 3 being multiplied to 4 square root of 6. The numbers on the outside first. 2 times 4, 8. Square root. 3 times 6, 18. Moving on now. Got to distribute one more time. 2 times that negative 5, negative 10. Ooh, this is going to be a big number. 3 times 21. 63. All right, so far so good. Now, this is a subtraction problem. First thing we got to do is break down the 18 and the 63, see if we can actually simplify those radicals. So I need my factor trees to help me. 18. Like I said, I'm going to use the numbers I already know, which were 3 and 6, okay? 6 breaks down to 3 times 2. Squiggle in time, squiggle you out, squiggle you out. I have a pair of 3s and a 2 left over. So that becomes the square root of 18 becomes 3, square root of 2. Now let's deal with the 63. 63. Oh, I'm not going to break my mind over what numbers to use because I use a 3 times a 21. All right. 21, though, breaks down to 3 times 7. All right, so I clearly see here we got a pair of 3s and we got a 7 left over, so that's 3 square root of 7. Okay, now to rewrite this problem, don't forget here that they have values in front here, okay? So this becomes 8 times 3 square root of 2 minus 10 times 3 square root of 7. All right? So 8 times 3 gives me this to be 24 square root of 2 minus 10 times 3, 30 square root of 7. Notice we cannot actually go any further because the square roots are not the same, radicals are not the same, so therefore that would be the answer.